Cool. Okay, so you can watch the video later if you want to hear me speak over and over. So this is going to be like a super beginner-friendly intro to Python, so it's okay if you've never used it before. If you have used it before, I hope we learn something that might be new, or we can like later on discuss other things. Python is a very general programming language, and by that I mean like it's not specifically for one task. So there are languages like SAS that are just for stats, for example. There are other fields that have kind of specific programming languages, but Python is very general, so you can use it for lots of different stuff. People use it to write stuff on the web, they use it to do science, they use it for data analysis, kind of all kinds of stuff. And if you have any questions at any point, feel free to stop me. So to get started, if you are going to be using Jupyter Notebook and you've installed Anaconda, open your command prompt, so a terminal in Mac or Linux, or Conda prompt in Windows, and type Jupyter Notebook. You can also have a dash in here. Everyone's okay. And then hit enter. And this will launch in your browser. It's not actually using the internet, because you can see here this is on your machine locally, so you don't need internet to do this. And then to start a new notebook, we're going to go new in the top right corner, and then Python 3. If you have only Python 2 here, that's okay. There will be a few things that will be a little different, but that should be fine. Like when you type Jupyter Notebook, or when you? Oh, new. What are the options? Conda root, you're saying, Elliot? Okay, yeah, try Conda root. Let's hopefully that works. So now you have this kind of just single line thing. I'll explain a little bit about what this can do, but you can make this into a really cool multi-purpose notebook, and that's why Jupyter Notebook is nice. So let's call this like testing Python. Do whatever you want. That was up here to change the title. So this thing here, this box, is a cell, and you can change the type of the cell. It's automatically set to run Python commands, but you can change it to instead be a markdown cell. And markdown is cool because you can do things like make headers, or you can do latex math if you're into that. Then if you do Shift Enter, it'll run that and then open a new cell. Again, automatically in Python. There's more resources you can look up for Markdown. So the nice thing about the Jupyter Notebook is you can kind of intersperse these code blocks with Markdown. That's kind of why it's useful. Let's talk a bit more about Python. So right now we've got a Python prompt, and you can just type anything like math into here, and Python will do it for you. So again, Shift Enter shows me an output. You can do like more complicated math. So the 2 stars is to the power, or the power of 2. And each time I'm doing Shift Enter to run it. So if you try typing 1/2, Shift Enter, because I'm in Python 3, this gives me what I expect, which is 0.5. But if this was Python 2, you would get 0. You can do something like 1./2, which automatically converts 1 to a float instead of an integer. So there are different types of data, and Python will, if you just specify a number like 3, it'll think of it as integer, but you can make it 3 dot, and that would be a float. So one way you can find out about what type of thing an object is, everything in Python is an object. So anything you create, any variable is just an object, but they might have certain properties. So if we go type 3, it's going to tell us that's an integer. Instead, I do something like type 3 dot, that's a float. Okay, that's not very exciting. We all have calculators. Any questions so far about getting it to work? No? Okay. So to make a variable, it's the name of the variable is whatever you type on the left, and the equal sign is assignment. So it's not an equality test. We'll talk about that in a minute, but saying name equals Madeline will assign that character set Madeline to the variable name. Now if I type name and shift enter, it'll show me what's in there. It's Madeline. Let's make it year 17 because it's 2017. Okay, so when I do shift enter, it's showing me the output, but you can also, let's say we had multiple lines here, like string 5. And then if I do shift enter, it won't show me the output. So if I wanted to print one of these and see what it was, you can use the print statement. So print year. And that will kind of display it to the screen. If you're using the terminal, this will also be the same. If you're using Python 2, instead of the brackets, it's just print here. Is anyone using Python 2, by the way? Otherwise, I'll stop saying that. Okay, I'll stop saying Python 2. So you can always, a cool thing about Python is it has kind of built-in help for a lot of things. So if you type something like help year, it'll show me the help page for the object integer, which probably isn't that useful. I don't really want to know what all these things are. But if you're using a more complicated function, it can be really helpful to just really quickly access the help page for it. If you don't assign a variable, Python doesn't know what it is. So let's say I tried to do something like print age. This is going to give me an error. Name age is not defined. So it doesn't know that age is a thing that I want to have be a variable. I have to first say age equals 25. Now if I do print age, it'll show me that thing. Okay, so I'm going to talk a little bit about data structures in Python, so ways you can arrange data. There's two that are kind of list-like or array-like. And the first one is called a list. And the way you make a list is something like this. So the square brackets are the outside of the list. They indicate that you're making a list. If this was Mathematica, it would be like curly brackets. I believe in MATLAB, it's round brackets. I could be wrong about that.
Still square.
Still square in MATLAB? Okay. Square brackets. Now you can put kind of anything you want in this list. What are some good fruit names? Banana. What? What was that name? Grapefruit. I feel like if it has fruit in the name, that's kind of cheating, but okay. So I did print fruits, and then it shows me all of my fruits. There are different operations you can do on a list. So if I do fruits, append mango. Now there's an extra fruit on the end, that's mango. You don't need to have all of the same type of object. So you notice everything in here is a string, a word, but I can add anything else. I can add, say, 3. That's fine too. You can have any mixture of data types in the list and it won't complain. Yeah.
I'm using this kind of Jupyter format. You still like go up. Yeah, previous commands. You don't have to type it.
I go up arrow. It just goes to the cell above. So you have to retype everything. Yeah. Good point. Okay. You can do like math on lists. So if I did something like fruits plus fruits, what do you think is going to happen if I do this? Twice as long. And what's going to be in it? Yeah, so exactly. It's just the first copy of it, and then it just adds a second one on the end. I don't think you can do like weirder math. Like if we did like fruits times fruits, I think it's going to be. Can't multiply sequence by non-int of type list. Okay, can't do that. Another type of array-like object is called a tuple. And this is different from a list because it's immutable. So for my list, you can change something in the list. So I'll talk more about slicing, but I can change, say, the first element of my fruits list to be another fruit, let's say. And then if I look at fruits, instead of apple, it's now lychee. But a tuple, once you make it, it's kind of fixed. You can't edit it after that. So a tuple is indicated in Python with round braces. If I try to change the first element of the tuple, it'll give me an error. So I can't do that. I can't change it like I would a list. Okay, so now I'm going to talk about how you would access different items in a list or a tuple.
Can you please explain why the hell I would want to use it?
So
Bothering me.
I don't know if I can give a good explanation. I think, does anyone else want to say like why tuples come up or have experience with this?
Like I've heard it's like good for like storing like temporary information. Like, I don't know. Like seriously.
Yeah, I don't know either. John, Elliot, Hudson.
Apart from sometimes you want something to not be able to be changed, and that just adds extra safety. I think it prevents bugs from changing what it not does.
I think there are
in
some
other languages. There are a lot of good reasons for them to be different. Like Python, for instance.
The other thing to note is that people is not actually trying to people is comma.
Is it what?
Comma.
Oh yeah, that's a good
People
one.
defined by the comma, not by the term. So
Okay.
if you want to return like multiple values, you can return A, comma, B, and that automatically creates a table. You don't have to put backwards to return. So it's like a nice shortcut for returning something.
Yeah, okay, that's cool.
Yeah,
And I think there are some
Oh.
interesting like set and uniqueness things you can do with tuples. Like you can
There's another data type called set that does that.
Okay, so we won't talk about sets.
Yeah, there may also be some efficiency things just because if something's immutable like that. Sometimes
Like you don't have to worry about
more or
yeah.
less efficient, but,
Okay, so basically there's no really difference.
yes.
Thank you.
Yes, I agree. That sounds good.
Yeah, unpack this.
Yeah, and then see, kind of a fixed object in place and keep referring to it later on. I can't think of why that would be useful for coding, maybe that's the reason.
Yep.
Anyways.
All good reasons. Okay, indexing. So how do you get at stuff in a list or a tuple? So to get the first element of something, it starts at 0 in Python indexing, not 1 like in MATLAB. This is a big kind of weird thing if you're switching from one to the other. There is a good reason for this. It kind of makes sense with the way that it understands slicing, but it can be kind of confusing. So you can enter any number in there and it will return that item, that index. So fruits like 4, will return the 5th element. There you go. There are some handy shortcuts. So like fruits -1, this is the last element of a list. You can also take a section. So if you go 0 to 3, so which elements will this return?
Is that a colon or a semicolon?
That's a colon.
And returning lychee through grapefruit.
So grapefruit isn't on there, which is kind of mysterious. But the way that the slicing notation works is it starts at the first thing in that semicolon or the colon. So 0 is the first one, and then it's up to but not including the last one. This is kind of confusing, but if you do something like fruits, 3 to, oh, sorry, and if I leave this blank here, it'll just do 3 to end. That's another thing that's useful. You do the same thing the other way. So fruits colon 3 is the same as fruits 0 colon 3. But you can see if I did fruits 0 to 3 and fruits 3 to end, this is the whole list now. So you can kind of, you don't have to worry about like changing that index there to kind of stop you in the middle of a list and then keep going. That's kind of the way I think about it being useful. This whole negative index thing, you can keep going. So if I did fruits -2, fine. What happens if I do fruits -100? Any ideas what this is going to return?
Am I like cycle over the list many times, or I don't know.
Yeah, I actually don't know either. So let's see. Oh, okay, let's index that arrange. That's probably good. That's about what you would expect.
That's what
this-
you would get if you put fruits 100.
Yes,
because
exactly.
we don't have that 100.
There is no 100th element.
It really just exists if you're copying the list on the other side, and not as if it's periodic.
Thankfully.
You can use the function len to get the length of a list. Or if we did len with that tuple, it's 2. All of the slicing is the same for tuples, by the way. So you could do something like fruits. This is just the whole thing. Also the whole thing. So you can kind of combine all of these notations in whatever you want to get whatever part of the list you want. Okay. Any questions about slicing lists? Okay. I'm going to talk about if statements. So an if statement is a pretty useful thing in programming. It allows you to check a condition and then do one thing if it's true and do something else if it's false. So the syntax for this in Python is if, okay, so let's make something string. I'm making this list S2. Now the syntax for an if statement is if, and then whatever condition you want to check. So if I want to see if this thing is a string. And remember how we were using the equal sign to assign a variable? So here it's a single equal sign. To check if something is equal to something else, it's double equals. So briefly, before I keep going, if you want to check something like 3 equals 4, this will return false. You can do something like 3 not equals 4, that will return true.
What does it give if you do 3 equals 4?
Like assignment?
Yeah. So you can do it because it's
Yeah. I mean, 3 is kind of like a variable that you don't have to assign. It just assumes that it's
I don't think you
3.
can use like numbers at the beginning of the
Right.
No. Like if I wanted this to be like
So you
3
have to
high,
say, yeah, I don't even think that would work.
it's thinking about it. No. Doesn't want that. Okay. So if this thing is a string, it's my text, and then you do a colon, and then it will automatically indent a tab. Let's do it as string. Now we can leave it like we can leave it like that, and because it's not a string, nothing is happening. We can also add elif or else statements. So elif is else if. So if this first condition is false, then it will go to the next one, else if. The difference between else if and else is else gets executed kind of no matter what if all conditions are false, and else if it will kind of check them one by one. I don't know if that's the right way to say it. There is a subtle but real difference between them. So it might matter, it might not for what you're doing. So let's say if this is integer, oh, also single quotes and double quotes doesn't matter. So you can also use double quotes instead of single quotes for a string. And at the very end of this, we're gonna catch everything else with else. So you don't have to have a condition here because it's just gonna do, if all these are false, go to the else. Oh, see there, I ended the string by accident. So when I ran this, because this thing is not a string, an integer, or a float, it executed this last statement here. Okay, next I'll talk about for loops. So a loop in programming is a way of getting it to do something over and over that you don't want to manually have to say do this 100 times, something like that. There's a few different kinds of loops. There's while loops and for loops. The main difference is that a for loop, you kind of preset how much it's going to run, and a while loop will keep running until some condition is met. So these are kind of, you can get them to do similar things, but you might want to use one or the other depending on the situation. So let's make another list of numbers.
Model, can you scroll?
More?
No, doesn't.
So the syntax for a for loop, start with for, kind of like if, for and then space. And it's the same kind of thing where the statement is first and then a colon. So in this case, n is like a dummy variable that will just take all of the things in numbers as it iterates over them. This can be anything. It could be like I, it could be like hello. Doesn't matter what you call that. You could also write this if you wanted to know what part of the loop you're on. You could say something like for I in range length nums. I think it's better to do it the first way. So just as an aside, range
To put list bracket from that it'll show.
oh, the actual list, okay. Yeah, so in this case, it's giving me like something to iterate over, but if I want to see like, right, just instead. So we'll return a list from 0 to 4, or 0 to 3. Okay, let's go back to the first way. So you can nest loops. You can nest loops and if statements. You can nest anything you like. So what this is doing is for each of the things in this list, it's going to take the modulus or remainder, division the remainder. And if it's 0 and divided by 2 is 0, then, or 0 remainder, then it's going to say even. And if it's not, then it's going to say odd. Oh, sorry. Change the variable from my sheet. So again, I is this dummy variable that we're looping through the list with. Odd, odd, even. Cool. So a string is kind of like a list. Like you can iterate over it, you can index it, you can slice it. So I can do something like vowel. And it'll give me the third element of this string. So you can loop over all the characters in a string, for example. You could do like for vowel and so that printed at each step of the loop one of these things in the list. Okay, this is all very fun, blah, blah, blah. Let's talk about functions, which is something that is super useful in programming. So we've already been using functions. So like print, for example, is a function that does something. Len is a function. There are other functions that Python kind of has automatically defined, but you can also define your own functions. And the way you do that is with this def command, and then we're going to do the name of the function. So that can be anything you want to call it. And then in the brackets here, you put whatever variables you want your function to work on. So we're going to say, take two numbers, num1, num2. And now we do colon. So this triple quotes thing here, this isn't necessary, but this is something that if you're writing functions is super helpful to include. It's called the doc string. And you can put kind of help information here about what your function is doing. So this takes two numbers, input. I'll show you later how you can use this doc string. So let's make something called SS. For the first number, for the second number. Then this return statement, whenever you run the function, it will spit out whatever is in this return here. So you can return more than one thing. You can return, say, this thing and also the two numbers. You can make any other variables you want to return them as well. So I'll show you how that works. So now if I run this, nothing happens because I just made a function. I haven't called it yet. But to use it, you do something like sum of squares. And now this spits out this SS thing that is inside the function. If I try to look at SS, it's not defined because it only exists inside this function. It doesn't have kind of a definition outside the function unless I specifically defined it. You can also set the output to something. Now I basically save the output of the function. I've assigned it to this variable sum square. And now we've defined this doc string here in the triple quotes. If I do help sum of squares, it'll conveniently return to me this doc string. So you can, if you're making your own functions, you can put stuff in there that helps you remember what you were doing when you made it, and then helps you know how to use it. So let's say we want to make this also return some of the numbers cubed. You can change it like that. Now if I run this thing, it's going to output. Wow, look at that, it's a tuple. And again, I can, if I were to do this, so assign the output to this variable, then it will just be that thing. You can also do something like this. Some squares, some cubed. And now the output has been split into these two variables here. Yeah.
Now, if you want to know this variable, you're asking is integer or string, for example. How do you know that?
So if you just wanted to look at the output without assigning to a variable, you could just wrap it in the type function. Or you could do this, where you assign it to a new variable and then check the type of that thing. That's an integer.
Do you know if there's a command to once you have the object with two numbers to access just one of them?
Yeah, so if I did this one where I just had it like 1.
Right.
Yeah, so then if I, so this is a tuple now. If I just want the first one, you can slice it like a list.
Oh, okay. So in this case, it works just like.
Yeah, it basically functions like a list after that. You can also kind of force it to be a list by wrapping it in the square brackets. And now it's not a tuple anymore. I'm sorry. Let's do this way. Oh no, never mind. It doesn't work. So now this is a list, but I've already split it into my separate variables. So it doesn't really matter how I did that. Any questions about functions? Yeah. Instead of a tuple, you could say, go like this. So now I've just put my two things that I want to return inside square brackets. So now if I run it, it's a list. If I just look at the output, it returns the output as a list instead. So you can kind of, I mean, you could also do it. Yeah, that's probably how I do it. Like inside the function, just make it a list on output. Don't need them. Cool. Okay. So the last thing that I kind of want to talk about is some packages that Python has. So there are built-in functions in Python, but there are also way more things in packages that other people have made that you can use. And the way that you access those is using the command import. So if you installed Anaconda, you will have Numpy. The way people typically will use it is you can import a package and then rename it to something convenient so that when you're referring to it, you don't have to type numpy every time. You can just type np. So if I run this, ooh, okay. All right. Shh, I'm in Python too. Don't tell Elliot. Okay. So for whatever reason, when I installed Python 3, I did not install any packages with it. Yeah, so if you installed it with Anaconda, you should be fine. This should work. If it didn't work, we can talk about it later. So Numpy is a package that has a lot of like array manipulation stuff in it and vector kind of operations, which is super useful. So you can make cool things like, let's call this array. So a range is kind of like range, but a bit more flexible. And it is this, you can see it's wrapped in this thing called array. So it's specific, it's not just a regular list anymore, it's a NumPy array. And here what I've done is by typing np dot, after the dot can come any functions that NumPy has. You can make this thing, okay, well, this is kind of what we talked about before. So this is similar to this array object, but it's not an array, so it's a bit different. And this is just a regular list. If I go type array, it'll show me that it's an n-dimensional array in NumPy. Whereas type list is list. Why does this matter? You can do handy vectorized operations on arrays that you couldn't do on lists. So if I want to do something like array squared, this will square all the elements in the array. If I try this with the list, so it doesn't want me to, it doesn't let me do those kind of operations on a list. I would have to go through the list kind of element by element and then do it, which you can do, but often these kind of vectorized versions are more efficient. There are lots of functions you can run on these arrays. So reshape takes this kind of one-dimensional thing and makes it into a 5x3 shaped thing. I try to reverse this maybe. So now it's a column thing instead of a row thing. I would do 115, I guess, to make it back into a row. You can do something like array.mean. This is the mean of the whole thing. If I went back to this version, this reshaped one, it now has 2 dimensions instead of 1. So I can do the mean over a certain axis, let's say. Array.mean axis equals 0. So what this does is it calculates the mean of each of these. I think the 0th axis is the rows. No, in this case it's the columns. There's 3 columns. So I always get 0 and 1 mixed up for what they actually refer to as axes. So whenever I'm actually doing this, I have to like look it up or like try both and see what it does. So do not worry about not remembering what that does. So it looks like, because give me 3 numbers, yeah. It's doing the mean of this one, the mean of this one, the mean of this one. If I did axis 1, that would be the mean over each of the rows. Okay. Another cool package you can use is called Pandas. I hope I have this one too. So Pandas is a data frame manipulation package. So if you've ever used R, R uses these data frames that are easy for like indexing and viewing the data and plotting and stuff like that.
Like a spreadsheet, Excel spreadsheet.
Yeah, so it's like an easy way to work with like a spreadsheet type format of data. Okay.
Means so much
Hmm?
Means so much better.
So let me see. Did anyone download the sample data set? Okay, so this one. Because I don't think people did anyone do it? No? Okay, we won't talk about that. But you can easily import CSVs with Pandas. You can then show the data, you can plot it, stuff like that. Let's just make up some data instead. Anyone know offhand how you make a data frame? Hmm?
I put the B in half left.
Okay.
Yeah,
Dictionary?
like,
Yeah, it needs to have like column headers and stuff, right? Okay, I'm only gonna try this like one more time.
That's your cul-de-sac.
Oh, this one. We're not going to do that. If you are not using Pandas, another thing you can use for plotting is matplotlib. This is typically the way that I use it. I import this pyplot portion of the matplotlib library, and I'm going to rename it PLT. And let's say I want to plot some data. An array. So kind of the quick and dirty way to make a figure would be plt.figure, which kind of makes this figure object, and then plt.plot. And then finally, actually in IPython, I don't know if I need to do this, but yeah. There's a way you can set IPython or Jupyter to kind of automatically display your plots inline. So if you're using it more as like a document of what you've done, you can have it nicely show them instead of in this extra window here. But yeah, so this is my really quick plot of X versus, or Y versus X. And with that, we're basically out of time, so I'm going to stop there. Are there any questions before I go out of this?
My comment is that if you're doing this in the terminal, you have to be like really fussy with your indentation.
Oh, like
We should probably
the if
mention
and stuff like that?
just all of it. Like it's like, yeah. You have to
Yeah.
have the exact right number of tabs. Has to be tab, can't be spaces.
Yeah.
So like Jupyter Notebook kind of does it for you, where like press enter and then you have tab and it's lovely because you know what you're doing. But if you're writing like in a text editor, if you have to like, have the right indentation.
Yeah, so it's probably not a good idea to like write scripts in say like Notepad and then try to run them. If you're gonna write a script, you can use like some text editors have kind of automatic syntax highlighting and stuff like that. Yeah, and Anaconda has a spider, which is a nice IDE. I'll just quickly open that.
Yeah.
So if you use something like, oh man, this is super small. Spider has like this window here, which is where I'm going to write a script, and then this window here, which is like the prompt. I'm going to make it bigger really quickly. So if I just do this, yeah, so it'll throw an error because it expected an indentation, didn't get it. So let me try this again. And I'm sorry, I'm still using Python 2 here, so I'm doing print differently. So it's 4 spaces. I think if I use tab, it's not going to work.
Really? Because for me, it only works if you use tab.
So you specifically.
Oh no, tab works
so
too.
you use tab.
Wait, really?
Yeah,
No, in the
Okay, explain why.
nature, it's fine, doesn't matter.
it will use tabs, but it's highly recommended not to use tabs.
So like if I'm
because-
writing like a text editor.
Yeah.
Yes, and it's because the number of white space characters matters. So if you use a space.
And that's operating system
tab
specific, right?
Or a space in foremost spaces, that doesn't get caught as the same indentation.
Right. But if it's just a tab, and a tab isn't just a tab.
That is
The tab is one character.
not equal to 8
It's equal
spaces.
to 8. Oh, okay. Yeah.
So it's weird because if you have your editor set 4 or 2, whatever,
Yeah.
it will not
I
operate.
see. Because I've been running scripts